Okay, so let's get started. We're going to be taking a look at setting up and working with our drive-by-wire throttle mapping using our throttle target table within our programming here. So we've covered how to set up and work with our drive-by-wire PID gains, our feed-forward table, going through and setting up our pedal and our plate sensors and getting that all calibrated. Now we're at the point where we actually fire up our engine and start to use the drive-by-wire system. So what we're going to do here, a couple things before we jump into taking a look at how we can set up our target table here in a variety of different ways. A couple things I want to point out. So the first thing here is that I've set the when stalled option to quiet throttle. Once I've calibrated it, I had it set on run throttle initially so that when we were key on engine off, the throttle body was active and we could do all of our testing without the engine running. So we set up our PID gains, our min and max clamp, as well as our feed forward table. So that was all configured when we were just key on engine off. Now that we want to actually have the vehicle fire up and run and start to work with our throttle target table, we don't want that throttle constantly running. It's super annoying. That buzzing, the high frequency buzzing is definitely going to get old. So I set it to quiet throttle. I wanted to point that out. The other thing I want to point out here is that our feed forward table, I did go back in here and just touch up some of the values. You can see that they're a little bit more linear compared to what we found in that last tutorial. Usually I go back in and check my work with the feed forward table after I know the system's all functioning, everything's good, the PID gains are all excellent, min and max clamps are all sorted out. I just go back in and double check everything. So I ended up with something a little bit more linear than what we found in that last training module. Just wanted to point that out if you're comparing what we saw on screen in the last training module to this one. Now what we want to do here for the throttle mode is go from our setup and go to on, because now we actually want this to go into its fail-safe protection and do the checksums between the throttle position and Excel pedal position sensors. So that if there's a fault, anything's going on in the system, it'll flag itself and it'll shut the throttle down and it'll give that fail-safe protection so we don't get a runaway throttle. Now what we're going to do here is take a look at our throttle target table. This table is where we call out our pedal plate relationship. So what I want to do here is just simplify this table up a little bit. We can find the table is currently set for engine speed versus Excel pedal position main. What I'm going to do here is set this table up so that it's just going to be based on Excel pedal position main. We don't have to have a three-dimensional table unless we're trying to get really creative and do some fancy things with the drive-by-wire programming, which we're going to talk about here a little later in the training module. So the first step here, just to get things going, making sure your mapping is correct and making sure your vehicle is going to drive pretty smooth, is just setting your table into a two-dimensional axis, which is just based on our Excel pedal position main. If I click X here, we're going to go to our Y-axis. We're going to go into our box right here and then set to none. We're going to get rid of this Y-axis. Then we're going to go to our X-axis. We're going to go to that little box. We're going to go and type in here APS, and we're looking for APS main, which is the Excel pedal position sensor main. Grab that option here and click OK. Now we'll go to initialize axes. The table is going to be based between 0 all the way out here to 100% in our Excel pedal position movement. We're going to map our actual opening of our throttle blade relative to our Excel pedal position sensor. This is setting our pedal to plate relationship. So we can change dynamically the way the car drives, giving it more or less throttle response, or trying to characterize a really large throttle body that we've installed on our engine. We can improve the drivability with 120 mil throttle body compared to something like a 50 mil throttle body, which is much easier to calibrate and tune. So let's go ahead and click OK, and let's talk about this table here. We're going to first go over setting up a smaller drive-by-wire throttle body. Let's say you have a 50 or 60 millimeter throttle body. It's relatively small. They're going to be pretty linear between our throttle angle opening and getting the airflow into our engine. So we're going to find that there shouldn't be a lot of drivability problems with a smaller throttle body in the drive-by-wire control. We can usually set a smaller throttle body to a relatively linear pedal plate relationship. So that means that if I'm at 100% here on my Excel pedal position sensor, I want my plate opening 100%. If I'm at 0, then I want my plate opening at 0. So I want it fully shut. So we're going to go here, Shift H, we're going to go and interpolate between all the table values. We've now set a 1-to-1 relationship between pedal and plate, and this should drive like a cable throttle body. This is going to be simulating what we'd get out of a mechanical-based throttle body. What we can do here is just real quick, I'm going to fire up the engine so we can test this out and just see what this is going to look like. So if I go ahead here on the simulator and fire the engine up, we can see it's running right now. We can see that I'm off the throttle. My APS main is 0. My TPS is showing 0. I'm going to go ahead and I'm going to push down the throttle here. So let's go ahead and give it some throttle input. And now what we're noticing here, the TPS main and the APS main are identical to each other. They're holding at a 1-to-1 relationship. So no matter where I put my Excel pedal, my plate is following that. So again, on a smaller throttle body, this is perfectly fine. And we might have to tweak it a little bit, but usually this is a good starting point. Let me go ahead and shut the engine down so that annoying buzzing noise goes away. So the next thing we're going to talk about here is if we're in a situation where we have a large throttle body installed on our engine. If we're comparing the throttle body sizes purely based on the surface area of our throttle blade, if we have a 50 millimeter throttle body, the surface area compared to a 100 millimeter throttle body, the actual amount that we see on our throttle blade, if we tip the throttle blade open the same percentage opening, so let's say it's 5%, there is going to be a considerable amount more airflow coming into the engine with the 100 mil throttle body compared to the 50 mil throttle body. That can be problematic because there will be a lot more engine torque production out of the engine at a very low throttle angle. That can create major drivability problems, and in fact, it can almost be so unreasonable to drive, you get a lot of surging and bucking as you try to hit the throttle. We can dampen a lot of that out and improve our drivability with a large throttle body by going in here to our eThrottle target table and setting our pedal to plate relationship in a more unlinear fashion. So how do we do that? Well, if we take a look here, usually 50-60% throttle and lower. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.